Recording is about to start. Okay, start recording already. So I come back to my original screen here. Go back to my screen here. Yeah. So everybody is here. Here. So one is missing. All right. Now your pointer, your pointer for your paper one. So normally I select those question has the same format as this one. Okay. So your P5 question one will have a similar format. Okay, what I mean by format is they will give you this statement. Yeah, they will give you this statement here. This one will be always standard lah. So this one, it will be similar. Yeah, you will see this for tomorrow paper. You will see this kind of thing. So is a what do you call that? I choose the paper that have a similar format as this one. Now, so what you need to do is, again, for question number one, you need to try to make use of the variable. So as I told you last time, you can use, make a table to write down the independent variable. Something that you vary. You can also have the dependent variable, something that you measure, and then there is a constant. All right, so these are the three things that you must be aware of. Okay, so let's just have a look here. I like everybody to read the question first. I give you maybe 1 minute. Yeah, can you read the question first? If you got the file I shared with you just now, you can have a read at this question here first. After that, I'll ask some of you to tell me what do you think is the variable that we have to choose. 1 minute from now, read first. I'll come back later on. If you got a paper with you, you can also start sketching the table also, so you can compare your answer with mine. Yeah, if you got a paper with you, foolscap ke apa, tulis saja lah, tulis on the spot so we can practice. Yeah. Alright, it's about 1 minute already. I want somebody from the center. Yeah, center here. Adila. Yeah. Adila, are you there, Adila? Oh, no response. So maybe not so good the signal maybe. Other than that, Ian na to. Ian?
Yes, sir.
Yeah.
Yes.
What do you think is the independent variable and the dependent variable?
Independent variable cross-sectional area. Sir. The
Okay,
dependent
so
variable is the spring constant.
sekejap. Independent is A.
Cross-sectional area.
Okay. Cross-sectional area. And then this one is the K.
K.
Which is the spring constant. All right. So these are the two things that you. And then what about your constant, Ian?
N, the number of turn, the density, and the thickness.
Okay, thank you. Number of turn, the density, and we also have the thickness. All right, thank you, Ian, for your explanation here. So I'd like to ask somebody at the bottom now. Sally lah. Yeah, Sally. Is Sally here?
Yes.
Sally, can you hear me? Yes. Sally, can you explain these two sajalah? How can you find out the cross-sectional area and the spring constant?
For cross-sectional area, measure the diameter using probably a vernier caliper.
Okay. That's all.
And then use the formula d divided by 2 to get the radius, and use a is equals to pi r square to find the area.
So you'll be something like this. Am I right?
Yes.
Any particular information you can mention here to improve your reading?
Measure the diameter at different orientation and perhaps take average.
Yeah, so maybe you can say repeat now. Repeat D at different what again? Different direction.
Different orientation.
Orientation or different
Position.
position. And take average. Alright, so these are the things that you must be aware. Thank you, Sally. Now I want somebody from the top. From the top here we have Amin kemarin sudah. Amir lah. Ya, Amir. Ya, Amir is online now. Ya. Amir, kalau K macam mana K ya? Payah ni K ni. Ya.
Pakai Boyle's law, cannot.
Again? Hooke's law.
Hooke's law.
So use a Hooke's law. So how can I use the Hooke's law again? Can you be more specific?
Force is equal to KE.
KE. So this one is the load.
Force.
This one is the extension. So that means you need to describe how you set up the spring constant, right? So you need some sort of retort stand to get the spring to extend, and then you find the extension from here, right?
Yes.
Yeah. And then you need to mention the extension will be the final initial position of the spring lah, and then the F will be the load lah, the load of the load you attach the spring.
Force to constant, sir.
Apa tu?
Force to constant magnitude-nya.
Because this one is the spring constant, you need to actually, kalau benarnya you need to have different load pulang tu, so that you can plot the graph. So from the graph panjang pulang you punya cerita ni, so you use different load, and then you plot the graph, force against extension, then you get a straight line, then this gradient will be the K. So the gradient is equal to K. So panjang pulang dia punya cerita. I can think of this pulang. Kalau spring constant, the only way to do is you use the Hooke's law, and then you set up the apparatus, calculate the extension, and then you vary the load, you plot a graph, then you get the spring constant from the gradient. Yeah. Itu saja kali lah. Alright.
Okay.
Thank you, Amir. Now we go back to the center here. We have Adila. We try Adila again. Adila, you there, Adila? Ini Adila betul ah? ADI, yeah, should be Adila, yeah. Okay, Adila is not here, so we go back to some. Ada Fadli already here. Okay. Inshira lah, yeah. Inshira, are you there, Inshira?
Yes.
Okay, Inshira, can you tell me about how can I find out the density and the thickness? Number of turns sanang lah, kira saja kan? Yeah. Density.
Density, mass over volume.
Alright, so sorry. Density, you need mass over volume. So the mass, what kind of instrument you use?
Apa ni? Triple beam balance or like
Wow.
electronic.
Wow, okay. Triple beam balance. There's sometimes they use the top hand balance.
Balance.
Yeah, and so on. What about the volume? Yeah. Volume of that spring. This is the spring. Macam mana kau cari dia punya volume? For me, I have a hard time. Yeah, if it's a solid cylinder, look like this. If it's a solid cylinder, it will be pi r square h bar, the volume. Tapi this one is a spring bah. Spring itu kira banyak lubang in this coil here. So, what do you think kalau in your lower secondary science or whatever, if you have a irregular shape, what do you use to find out the volume?
In my head, pakai yang masukkan dalam air and then the volume of water.
So use a measuring cylinder lah. Measuring cylinder to get the volume. I hope the measuring cylinder can fit the spring lah. So that's how I think also. Yeah. Don't use beaker. Yeah. Don't mention beaker. Beaker
Sir.
is not a good. Yes.
Bukan namanya Eureka can kah?
Oh, there's another one, the Eureka can. Can also? Yeah. Boleh juga. Thank you, Danish. You can also use the Eureka can, which is a displacement type lah. Yeah. Boleh juga. We roughly tell them je lah. We don't need to draw lah. And last but not the least, Inshira, what about this thickness? Yeah.
Using micrometer screw gauge.
Okay.
Gauge.
Micrometer. So do I need to do? No need, because that's the thickness is the diameter already, okay. So no need to take average or what lah. Maybe can you say maybe repeat
Take from
at different position, yeah, because the wire tu panjang kan, you can maybe take from the one on top here, one at the bottom there lah. Alright, so these are the things that you must be able to explain during tomorrow paper 5. Alright, so you make a table something like this. Okay, no need to rewrite just make a table look like this also can. I don't really force you to use a table. If you are not comfortable of using a table like what I do here, you can use the standard one lah. Write down the steps one by one. It's up to you. Kalau you want to use table saja lah. Whichever you are comfortable. And then last but not the least, we have the analysis. Okay, try to get the analysis done here. Oh, maybe analysis I just do it here. Yeah. So analysis. All right. Now, analysis, we have to look at what we want to do. We have a K here. We have a K here, and we have the A here. We have a A here. Yeah. So how can I get my beta? I want to get my beta here. So if you split the A outside, it will become something like this. Beta rho t to the power 4 over n, then 1 over A 3 over 2. So can I say plot lah? Okay. Plot K against 1 over A 3 over 2. Yeah. Then your gradient will be beta rho T4 over N. And then you can get the beta down here. Okay, sorry, around here. You can get the beta, which is equal to gradient time N over density T to the power of 4. So you'll get this analysis done. So normally when you set plot against something, you get a 1 mark, and then the constant is another 1 mark. And the last mark, don't forget to mention, the last mark is valid if straight line. Okay, look at the analysis again. There is no y-intercept, right? So it must be straight line through origin. Yeah, then you should get all the three mark here. And then of course the safety precaution, you have to think of your own. So I just add on here, think of safety precaution, and then plus any additional info that can help you to make the experiment more precise. So let's just have a look here. The analysis, yeah, plot against K against 1 over A 3 over 2, and this is the gradient that we did. So it's a 3 mark pass through the origin. All right, so this one you go and have a look on your own, because I don't have time. I just want to quickly go over question 1 and 2. So we look at the next one here now. Okay, maybe you don't do this one. We do the third one. Yeah. This will be very similar again. If you look at this question again, you will realize that the last sentence is the same format. Yeah. Even you look at the second one just now, they all have the same format. Yeah. So tomorrow you will see this same format also. Okay. Look for this. Look for this format. Yeah. So this is the format that you will see tomorrow. So without further ado, can you read for me first this question number, what is this about the extension thing? Yeah, can you read for me first, and I'll ask you again which one is the variable resistor and independent variable? Yeah, independent variable, something that you vary. Dependent variable, you read first what I write down the table. Right, so another, there's a bit more lah, you read first lah. Yeah. Okay, so let's start with somewhere at the bottom. Yeah. Sahibul, are you there, Sahibul?
Yes, sir.
Yeah. So after you read the expression of them, what do you think is the variable and the constant? Yeah.
independent cross-sectional area.
Okay.
Frequency, apa ni? Dependent variable.
Which one you read ah? Yang
Salah
ketiga
kah?
lah. Oh, yang ketiga. Salah, sorry. I think you
Ajab
read the wrong
sak.
one. It's okay. I ask another one. Sekarang I come back to you. Yeah. From the top. Asman. Oh, Asman. Are you there, Asman?
Hello, sir.
Yeah.
The extension E kah dependent variable-nya, sir?
Okay, we tulis saja dulu. Ngam tak? Sekarang baru we running ah. Yeah.
Atau kalau independent sir? Independent is the D, sir.
Oh, sorry. Okay. So this one
The
must be.
diameter.
This one is
And
the
the diameter.
This one must be the E, which is what? E is the
extension.
And then the constant?
F.
F.
The force applied.
Anything else? Satu saja.
L also.
L. Okay, that's all.
That's all.
Oh. What about E? Do I need to mention E, which is the Young modulus?
Itu bukan macam constantnya. No, anda constant je yang kami cari.
Oh, okay. Oh, you want to find.
E.
Oh, you want to find the constant. Oh, yeah. Correct. You are right. So, no need to write this one. Ngam. You are correct. Yeah. All right. Can I have somebody come back to maybe Sahibul tadi lah? Yeah, Sahibul. I hope you read already, Sahibul.
Yes, sir.
Yeah. Can you tell me the top two first? Macam mana kau cari the diameter and also the extension? We start with diameter first lah.
Diameter pakai apa ni? Micrometer.
Oh, micrometer. Alright. Do you need to add anything to
from different measure from different position?
Okay.
And average. Take average.
Alright. Micrometer. This is a wire, betul? Diameter of cord. Yeah. What about E? What about E?
E
extension.
Macam mana kau sambung attach lot and spring?
Okay, so maybe right there. Attach a lot to the spring. Then?
And lepas tu extension equal to final length minus initial length.
Okay. That's all?
That's all.
I mean, how do you measure the final length and initial length? You need something to use a ruler. Yeah, use a ruler only. Pakai ruler saja. Any name?
Meter rule.
Meter rule. Yeah. Thank you. So this is the good enough lah. Yeah. All right. So let's come back to the front here. We have Fadli. I just saw Fadli here. Fadli, are you there, Fadli?
Apa sir?
Macam mana kau cari the length of the spring? Yeah. length of the spring. And also the force lah. Boleh cari ke tu force-nya tak?
Kalau pakai force gauge dapat tak?
Force gauge. Tapi force ni come from mass kan? Kamu gantung arah wire tu. The force come from the mass, right? So, macam mana kau dapat the value from the force from the mass? For example lah, ni wire-nya. This is your wire. Then you attach the mass, right? Then this mass will create a force. Yeah, which is the load you experience kan? So macam mana kau get the force from the mass ah? Apa relationship ya force and the mass ah?
Cari weight.
Okay, you can find weight. So weight is equal to
mg.
right? So at the end, what kind of device you can use to measure mass ah?
Mass balance, electronic mass balance.
Okay. So use electronic balance. Okay, can also electronic. Normally we use top pen balance lah. Okay, top pen balance. Or sometimes you can also use the Inshira punya triple beam balance. Yeah. So try to give the name of the balance lah. Yeah. So the mass kau cari macam mana lah. What about length ah?
Pakai meter rule.
Meter rule. So this length here you can use a meter rule. Meter ruler. Yeah. No need to make so precision lah. So done already lah. Alright, thank you, Fadli. So here is the summary of your measurement. Who are the variable and who are the constant and how we are supposed to do this. Of course lah, we will have maybe more to do, but this is roughly what you should be able to do in the exam lah. Just a little bit of question. I'd like to ask someone here. This one is Kashfi. Kashfi. Ada si Kashfi? Is he responding?
Ada, sir.
Yes, Kashfi. Can you help me to answer my question? Macam mana sir tahu D is independent and E is dependent? Any statement from the top can clarify this one. Kadang-kadang paning ba, you know?
Ada, dia cakap ada the first line. Dia cakap investigating how extension depends on diameter.
So you change the...
So artinya, yeah.
Oh,
Simplify dah sikit tu.
so extension depend on diameter. So you change the diameter and see how it depend, how the extension depend on it lah.
Will affect extension.
So can I make a statement kah? Macam kalau ada statement macam ni. So meaning that the first one is always the dependent variable, and the second the one after will be the independent variable. Can I say like that?
So let me check yang other question.
Okay, come. Let us check here. Let us check here. We check the first one tadi lah. First one adakah ya ada yang beritahu statement kah? Tu nah this one. How spring constant vary with A. So the first thing must be apa tadi Dependent.
Independent. Dependent.
Ngamba. Yeah. Dependent variable. Then this one must be the independent variable. Yeah, I think it's correct now. Yeah. So the first one sebelumnya begitunya vary or depend. The first one must be a dependent variable. So maybe those who are not sure which one should be the independent variable or the dependent variable, you look at the statement lah. Okay, you look at the statement. If this then followed by depend and then on the diameter, then that means this one will be the dependent variable, this one will be the independent variable. That means you you vary this one, then you measure this one. Okay, so hope this one will help you for tomorrow, just in case you mix up lah, you don't know which one is the dependent and independent variable. Next, we want to see the analysis, so I'll do the analysis here saja lah. So the analysis, jangan miss the mark is 3 mark tu always analysis is always a 3 mark. So the first thing you must say plot, yeah, because this one is a E against D. E against D. Macam mana? I don't have my D here. Anybody can help? I don't have my D here. Before you look at the
Bukan area ke Sir?
Huh?
Area. Pasal
Area.
D diameter kan Sir? Pi D square over 4 is A.
Okay. So that mean I need to rearrange this statement to become FL pi D square over 4 times E lah. Then maybe I write in some way here. What? Wait E equal to FL. Soalan ni lain lah. Because the D tu ada dalam the thing. Yeah. So we need to plot E against D. So you can make E the other side. You have F4L over pi D square times E. And then you make the D nya keluar. So become 4FL over pi times E bracket 1 over D square. Macam mana kah? Yeah. So you plot plot E against 1 over D square lah tu. Then you get a straight line where the gradient is 4FL over pi E. Yeah. 4FL over pi E. So kau punya E sekarang, you find your E kan? E will be 4FL over gradient time pi. Yeah. And then you mention will it if straight line through origin, because there is no y-intercept here. Maybe let us have a look at the scheme lah. Yeah, let's have a look at the scheme. See what does it say. Oh yeah, so E against 1 over D, and then this is your E. Payah this one sebabnya the E and the F, E and the D is not a direct one, so you need to modify. You need to modify the expression to include D into here. So without the D, you cannot do anything. Okay, I hope this one clear a bit of your doubt. So this one you will have 1 mark when you mention, and then 1 mark for the gradient, constant E, sorry, and then the 1 mark for the validity of the straight line. Alright, anything you want to ask me before we go through the question 2? Question 1 dulu So I'll just go through everybody here lah. Sally first lah. Yeah, Sally, anything particular you want to share with us for question number 1?
So far, I'm okay, sir.
You're okay with this,
Yeah.
Thank you. Sahibul?
Nada, sir.
Nada. So there's nothing to still you already know macam mana cari the variables sudah the 3 variable here.
Okay, sir.
Go to the next one. Rosiana?
Nada, sir.
Okay 15 mark ni Kashfi?
All okay, sir.
Okay. This one is who Muhammad. I just see the name. Let me check again. Always mix up. Danish. Yeah, Danish. Danish J.
Yes, sir.
Yeah. Ada Kandishe?
Ada.
Ada. Okay. We have the next one is Inshira.
Sir,
Yes.
how do I know macam which one plot against mana satu?
Oh, which one plot against mana satu? Alright. So Inshira got the question. So this one. This determine the subject. Yeah. So kalau is E sama D, you make E the subject lah. Yeah. E the subject. Kejap ah. Tadi sebut E the subject tu lah. See? I make E the subject here. So E against D lah. So this one is E against something D. It might not be D direct tu ah. Sebabnya kalau kau lihat dalam sini, it's actually 1 over D square due to the manipulation of the algebra here. And then kalau kau lihat di depan tadi lagi, the first one here. So the same thing also. So this one is this is the subject. So you make K the subject. So it will be K plot against something, yeah. So you'll be plot K against something with the A lah, yeah. So for this case it will be A3 over 2 macam tu lah. Boleh Inshira? Kira this one is the mastermindnya lah. Ani, this is the mastermind here. So tomorrow the paper 4, kalau you don't know which one plot against which one, you make this the subject. The first variable in this statement here will be the subject here. Alright, come back here again. So we move on again to Ian.
Sir, yang subjek ni sir, kalau terbalik sir, okay sir?
No, doesn't matter actually, Ian. Yeah. Even though the mark scheme ia punya subject is let's say dalam mark scheme the subject is A against B. Tapi kau buat B against A, it's alright as long as it mathematically correct, yeah. Bila you do the algebra, kalau ia boleh buat terbalik, then shouldn't be a problem. Yeah, you will not be penalized to Ian.
Okay. Sama force sir. Kalau pakai Newton meter sir, kali gravity lagi kan sir?
Newton meter tak payah, tarus. Kalau you pakai Newton meter, then tarus saja.
Okay, thank you sir.
Okay, next we have Adila. Adila. Bukan. Oh, log off sudah Adila, sorry. Fadli, yeah.
Okay, sir.
Okay. Danish, K? Anything to
Okay,
say?
sir. Nada.
Nada. Bazli?
Okay, sir.
Asman?
So far okay, sir.
Okay, thank you. Amir?
Atau sir, kalau tadi anda tahu cari precautionnya sir, macam mana sir? Macam eksperimen tu macam selamat. Sir, tadi anda tahu precautionnya apa? Macam mana sir?
Okay. Precaution itu you need to what do you call that lah? You need to have a very comprehensive revise on this paper 5. Memang kalau macam ni, kalau is about spring ni, not about spring, elastic cord, ia ada chances ia putus lah. So kalau ia putus, ia barat weight atau akan gugur ke bawah, it might hurt your leg lah. So you can set put a sand tray or whatever below it lah. Macam tadi is about spring kan, spring and lot. Maybe also that one ia boleh gugur. boleh terkena you punya tangan ke apa, so you have the safety precaution done there lah. So for example this one additional information, ni pun yang dah banyak cakap the safety ada tu nak way safety Google to prevent injury to eye because the elastic cord is moving or you can put a sandbox ke apakah. So Amir, kau punya soalan payah jawab tu Amir. Very hard to jawab Amir because
Okay.
ia kadang-kadang terpulang kepada eksperimen itulah. So kalau ia is about hitting stuff, you might want to use glove to avoid burn to your hand. If it's about macam spring ni memang wear goggle sama sentre lah. So very unique lah So please do me a favor lah. You go through the mark scheme here. Make sure that you are able to take down all the necessary information lah. So for example, see, we did mention this one. We did mention diameter at different area lah, and so on. Oh, this is something new. Use a set square to check the ruler is vertical. Oh, yeah, but because we've tried to find out the extension of the length, so the ruler has to be straight lah. Kira tambahan lah. Now we go to question number 2. Question number 2. I like to do this one, the second question. Okay, the reason I want to do question number 2 because it might help you for tomorrow. Right. So this is number 2. Alright, I'll give you a few minutes to read question number 2 first. Sorry. Can you look at this question number 2 here? We do this one once. Satu soalan sajalah. Then we are done for today lah. Last one lah, because it's already 12:17. Alright, can you have a read at this question first?
Sir, I have one question.
Oh yes, please.
About question 1 tadi, about like kalau extension na tu, we need to use meter rule kan to measure it. So do we have to draw the meter rule arah the diagram?
Better draw lah. Arah siringnya kah?
Okay.
Arah siringnya, then you set for measuring the extension.
Okay, thank you, sir.
Alright, so maybe now you have already roughly have the idea of what is about question 2 lah. So question 2, surprisingly, there are 2 formula or 2 expression given to you. So we have an expression R equal to E over I, and then we have another one. We have R equal to PT Q. So we have 2 expressions here. So you need to be careful what you should use. So let's see. A graph is plotted against log R against log T. Since it has R and T here, this is a T, this is a R here. This one don't have T. The top one don't have T, so we don't use this expression lah. Okay. Now, so in order to do this, you need to log the whole thing. Log the whole thing. So PT Q. I know I did mention to you logarithm will not be coming out tomorrow, but there is a calculation at the table there that you must know for tomorrow. So let me just finish this logarithm check first, then we can go through the calculation. This one log thing, I hope everybody did not make any don't make any mistake. Because when you do the log, then it's log R against log T. Sorry, log R against log, so we Q log. I always write log plus log P. So this one is a Y equal to mx plus c. Therefore your gradient is just simply q, and your y-intercept is simply log p. So this is all done lah. Here come the calculation I would like everybody to try. All right, so let's look at the information given to us. So this is the value of E given in the question, right? This is given. And then this is your I. And you want to find R. So where did I find R? How can I find R? So if you look at the first expression just now, this one, yeah, this is where we have the relationship of I, yeah. So you can come back here again. Put the image back here. So this is where you have your I. Resize it back a bit. Yeah. So this is your I here. So how to find R? R is actually E over I, yeah, E over I. So can I have everybody take out your calculator now? Let's do some quick calculation of this variable here. You have a paper with you, or you print out already? Yeah. Can you try it out first? Maybe 1 minute lah. Yeah. I'd like you to do for me the value of R. Yeah. This one first. Yeah. I'll ask one of you to give me the answer after this. Yeah. So I take a break first. I go and take a drink first. I'll come back come back later on. Yeah. Tarus with the uncertainty. Yeah. Also, try not to compare the answer. I know the answer is just next page. Try not to look at the answer. Yeah. We have 2 gone already. Yeah. Adila is not here from just now. Not so good. There is the internet. Yeah. Siapa yang hilang ni? Amin, Amir, Osman, Ian, Jira, Danish K ada. No. Alright, so I hope you have done already. So maybe I ask Basli lah. Basli, are you there, Basli? Ada?
Yes, sir.
Have you calculated the R already?
Uncertainty-nya 15.
Just give me the R first lah. Yeah, give me the R first.
Okay. 9.4, 5.9, 3.9, 2.5, 1.7, 1.1.
All right, thank you.
Okay.
Maybe somebody had done the uncertainty for me. So
Sir,
maybe.
sir.
Yes.
Kalau yang macam value 9.4 tu boleh kami buat jadi 9.5. Macam 5.9 jadi 6.0.
5.9 jadi 6.0. Oh, kerja apa?
Kira macam estimate supaya anda payah grafnya.
Ini saja. You need to look at this one, the value. Oh, this one belum lagi betul. Ini belum lagi dalam the graph ni ya. Now, kalau formula, anything yang belum dalam graph itu, you better at least 3 sig fig lah. Ya. Sekurang-kurangnya 3 sig fig lah. Pasalnya R ni kau masukkan dalam this one. You gonna put it into the log R. So kalau sudah you run off the value, then the log R will be a bit off bah. Okay?
Yes.
So I prefer you to check first lah. If this is in the graph already, this is you are going to plot punya. Maybe can lah. You look at the smaller scale, yeah. So for me, better don't lah. Yeah, jangan tukar jadi 6, jangan jadi 4, jangan jadi 2.3 lah.
Okay, sir.
Maybe we have Rosiana kali ya. Bukan Rosiana, si Danish kali. Danish J ya, Danish J. Danish J sudah you cari the uncertainty, Danish J?
Belum, sir.
Okay, belum. Okay, maybe we ask tadi sudah tanya, Wazir semua tanya, Amir sudah tanya. Amin kah? Amin. Amin sebelum tanya orang Amin.
Belum, sir. Masih cari.
Masih cari ya. Alright. Open to the floor sajalah. Anybody already finished the uncertainty?
Belum habis.
Okay.
So, macam nak kan cari uncertainty-nya? Aku dah dapat.
Huh? So, in order to get the uncertainty, I give you some hint lah. It's from here. So, the uncertainty of R over R is equal to the uncertainty of E over E plus uncertainty of uncertainty of I over I. Therefore, your uncertainty of R will be, you need to have a lot of calculation here because it's a very long, tedious calculation. That's why I want you to do this. This will be useful for tomorrow. Supaya tak panic esok. Yeah. So if you can do this, the one that I show you here, yeah, then tomorrow should be a smooth travel lah.
Sir. First one plus minus one.
I don't know. Let me check Tu scheme ya. Yeah, it's about 1 Yeah, it's about 1. Tapi you need to stick with, as I told you just now, kalau boleh 366 ataupun follow the best data lah, because ani belum lagi habis pa. Ani sekarang dipakai dalam sini kan. So you better stick with 2 sig fig or 3 sig fig. So for your case, it will be 0.97 lah. Jangan 1 Yeah, so it will be better with 0.97.
Sir.
Yes.
Yang 0.97 tu bukan untuk log R 10.3 itu.
You mean ani?
Uncertainty-nya kan tu.
Oh, okay. Sorry. Tu nah, uncertainty R is 0.9 to 1.2. 0.9 to 1.2. Just now Sahibu say 1 Ngam 1 kah?
Dah dapat, sir.
Telepon aku, sir.
Can you get 1? Can you get 0.9?
Aku dapat
It's
1.04.
Yeah.
Yes.
Point?
1.04.
Oh. Okay, thank you. So it's 1.04. So we have to lah. Choose 1 na to Yeah. So sini sorry. Yeah, ia ada no gapnya. So this is the value lah. Somewhere between 0.9 to 1.2. So 1.04, 1.0 siya lah. Yeah. I think should be fine if you write 2 decimal place. Yeah, can also 2 decimal place. Yeah, if you want to write 1.04 is fine also. Yeah. The most important thing is this one lah. Yeah. This one must be 2 sig fig or 3 sig fig. Yeah. Anyone already finished?
Dah, sir.
Amin, Amin, can you tell me the value?
Second column. Second row. Entah. Yang 313 itu 0.424.
Okay.
Next 0.205. 0.0956.
Huh? 0.0?
956.
Wow, getting smaller.
Next 0.0493. Satu zero lepas decimal point. 493. Then 0.0293.
Alright.
Salah.
So
239. Terbalik.
thank you. Alright, according to the mark scheme here, if you see 0.02, okay, 1.9, so should be fine lah. So until 0.02. You might want to ask me, if I leave the answer like this, will I get penalized or not? Yeah. You get that. For me, because this is not the last one. This is not the last one. The last one is here. So I will look at the last one here rather than penalize you here. Ya. Tapi jangan kamu round off berhabis lah. Ini jangan kamu round off berhabis. Jadi 1, 0.4, 0.2, 0.1, 0. This one 0 sudah patut. Kalau kamu round off, right? If you round off to 1 sig fig, this is 0.1. This one is 0 already. You see, 4, you cancel, you got 0. 2, you cancel, you got 0 also. So try not to use macam you give me more, you give me more sig fig, it's alright. Jangan bagi less lah, ya, jangan bagi less. So for me, this one I still consider okay lah, ya. Yang pentingnya karangan ni, okay. Alright, so let me see with the log R. Anybody do the log R already? This will be the last one for today. Overshoot a bit today, yeah. So maybe siapa bisa ini? Sally, have you done the last one, Sally? Log R?
I haven't calculated the uncertainty.
Okay, can you just give me the value of the log R?
Okay. 0.97, 0.77, 0.59, 0.40, 0.23, 0.04.
Correct? All right, thank you. 0.04. All right, so as you can see from the mark scheme here, there are 2 sig fig, 3 sig fig, and even another value of your answer here. So it all depend on your result from your R. Okay, so it all depend on your R. So if you can, you at least stick with the sig fig lah. So I think the last one, you need to have at least a 4.1, yeah, or maybe 4.0, because this one is a 2 sig fig, yeah. Do you know how to find out the uncertainty for the log? Anybody know how to find out the uncertainty for the log? Remember?
Change in R over R.
Yes, change R over R. So to get the uncertainty of log R is 1/2 log R maximum minus log R minimum. Okay. This one. So example, the first one. The first one will be 10.44. minus 8.36. And then you should get the answer. Yeah. Zero point zero five. Uncertainty tu nah. Uncertainty is of log R is 0.05. Good. Wait second row, third row. What is this Oh, 0.4 to 0. And row 2 between. Oh, okay. 0.4. Row 4 between 1, 2, 3, 4. 0.9. Yeah. Okay nah. So this one you will get. Oh, sorry. 0.05. So the uncertainty here will become 0.05. Wow, very hard to plot. Let me see the graph. This is your log R. So if you look at the log R, the smallest will be 0.71, 7273, 7475. So 71, 72, 73. So it's better we stick with 2 decimal place. So 2 decimal place would be just nice. Yeah. Easier to plot. Yeah. 0.05. Aduh, 0.05 is so small. 0.05 is only, this is one half only. Wow, so small the error bar. Yeah, so the error bar will be very, very small for this question. Alright lah, alang-alang lah. We see the answer. Siapa bisa ya? I ask Sally already. So maybe Danish ada? Danish K?
Apa sir?
Can you show me all the uncertainty for the log R? Sudah cari?
Kayap sir. Belum sir, belum.
Okay. We ask maybe Ian kali lah. Ian,
yang uncertainty R.
masih lagi uncertainty R. Okay.
Oh, sir.
Lagging lah. But Ian sajalah. Ian, you have the answer, Ian.
The first one aku dapat 0.04.
Oh, 0.04. Okay.
Second one 0.03.
Sekejap
And then 0.02. 0.02. Uh, 0.01 and 0.01.
Wow, if this is your case, your graph will be crazy because this is the log T, this is the log R. So your biggest tu nah sini. The biggest is 0.05, the smallest is 0.01. So kalau dilihat the error bar, wah, nada error bar ni. See, this is already 0.61. Oh, 0.01 ba? Oh, boleh. Sorry. Can. So this one will be one box only lah, 0.01. Yeah, because the division will be 0.01. Yeah, can. One box, 2 box only. So this is about 4 boxes. Yeah, 4 boxes, 3 boxes, followed by the last one is about 1 boxes. So doable lah. Yeah, doable here. Look at the scheme here. Oh, now you might not get penalized, Ian, because it's from your calculation also. Even just now, this one also we didn't get the answer, even though we use 9.4. Yeah, 9.4 from E over I, which is already the exact amount, yeah. R equal to, sorry, I mean this one. Yeah, E over I is 9.4 over 0.1. 0.1 kali sorry, it's 1. So it's memang already 9.4 bah. But then this one, yeah. You get the log R 9.4 is 0.97. 0.97 je tu ah. Oh, sorry. I mean this one. Okay. Ignore me then. Yeah. Alright. So I have some other 2 exercise for you to practice at home. You can try to practice and plot the graph also. Others print out the graph here so you can actually try and practice drawing. So I think that's all for today lah. Okay. Since I asked you already just now, since if you have no question, you may leave the chat room now. Oh, who's talking just now? Okay. Kalau no question, you can go now lah. Yeah. If you have anything to ask me, please stay behind. Yeah. See Kashfi. Kashfi, you want to say something? Is it? Oh, bye already. Yeah.
Thank you, sir.
All right. Bye.
Thank you, sir.
Bye-bye,
Thank you, sir.
Bye.
Sir,
Yes.
so yang R max atau it's basically yang our R and then plus 1.04 lah to. Macam
Yes.
9.4 plus 1. And then min is minus.
Min is minus. So you have to
Okay.
do the whole thing over and over again. Banyak kerja this one. This is a lot of work. But bear in mind, tomorrow I want this one only. Yeah. I want this one only, the one I
Okay.
highlight on the screen. Yeah. Make sure that you know how to do this. Yeah.
Log itu na payah lah sir. Yang R
Nada,
max,
log.
R min atau.
Nada. This one nada esok. Ini saja.
Okay.
This one.
Alright.
Alright. Bye.
So apa soalan?
Okay. Thank you sir.
Okay. Basli apa Basli?
Aku mau tahu macam mana cari R-log.
R-log. Mana?
Yang era table ujung sekali. Macam mana cikgu cari 0.97 itu?
Ini kah? You taruh log 9.4. Log 9.4. Log 9.4.
Satu saja sir.
Oh, pasal ya log ano kan? Ya sudah log R and then is 10 to the power of 3 bah. So you just put this is already 10 to the power of 3 kan? Sama bah. So simpan the value sajalah 9.4 saja. Dan
yang table sebelahnya tu yang 2.481 untuk apa tu?
You mean this one? This one untuk kau punya x-axis. Ni this one. Your x-axis. Kau plot, kau mesti ada 2 axis kan? This is your log T. And then this one is your log R. That's why you need the two axis. Ini untuk kau plot sekarang. Because sekarang you plot log R against log T lah. Ya tak, ni gunanya untuk kau plot saja tu. No calculation needed, just plot saja.
Oh. Thank you sir. Faham dari tadi.
Bangang okay. Good thing you asked lah. Yeah.
Sir, I have one more question.
Oh yes, please do so.
Yang R atau it's E over I kan?
This
And
one.
then the I itu it's over milliampere kan?
Yeah.
So tapi napayah bagi times 10 minus 3.
You mean untuk cari R ni kah?
Yes.
Mau.
Ya kan?
Oh, pasal sini
Aku
times 10 power 3 je lah. This is actually 9,400 minit.
Okay.
It's not 9. This is not 9 9.4 is actually 9,400 though.
Yes, okay.
Oh. Unless ini adalah, unless ini ia, unless arah yang sebut merah-merah ni, unless ia ohm lah. Kalau ohm saja, then it will be 9,004. Yeah.
Okay.
Okay, ya?
Okay.
Sir,
Thank you, sir.
Yes. Okay, bye.
for uncertainty answer, if addition and subtraction, kami campur kasih self-uncertainty.
Yes, campur saja.
Or is it kami mesti macam buat yang change in R over R plus?
Tidak payah. Just simply add it up saja. Let me show you last time we did one. I think it's a 5-2 this one. Tu macam mana ni? So this one you just simply campur saja tu.
The uncertainty saja.
Oh, you can straight away 5% of the total value. You see kan sini kan? 22 times 5% is 1.1. 33 times 5% 1.65. You get 2.75. So cara yang kedua, you can use just simply kali dengan 5% saja. You also get the same answer tu. So
pasal uncertainty-nya sama kan sir? But in case kalau uncertainty-nya sama sir, individual kan?
Yes, correct. Kalau ani dah sama, yes, you are correct. Yeah. Meaning that if this is ali-ali, then you have to campur ali-ali lah tu. Kalau sini 5%, sini 10%, so ali-ali kau buat, baru kau campur tu.
Okay. Alright, itu saya sir.
Alright.
Okay, thank you sir.
Alright. Anything else? Kalau ada, you can leave already. Sally ada? No, Sally don't have
For the uncertainty, right? For the just now the question, if like there is like the current, right, is given in milliampere, so during when we do the the uncertainty, do we have to include like 10 to the power of -3?
Okay, you mean for example this one lah.
Yeah.
You mean when we do here?
No. When calculate for the absolute uncertainty of the resistance.
Oh, okay. Do I need to put the?
Yeah. Do we have to like put like 1.0 times 10 to the power of -3? Yeah.
Okay, let me show you. Let me show you here. Since you asked already, I show you here. So uncertainty of E is E equal to uncertainty of R over R equal to uncertainty of E plus delta I over I, right? So let's say the first one, 9.4 plus minus 0.1, is it? Okay, yeah. And then your I will be 1.0 plus minus 0.1 also, right? Yeah. And then you said it's a milli, right? So it will be 1.0 times 10 to the power of 3 plus minus 0.1 times 10 to the power minus 3, right? So when you put into here, you see the magic here. The what do you call that? The time 10 minus 3 gone. Can you see this? This one actually gone.
Yes.
So it's the same thing you do straight away. You see, it's the same thing you do straight away. Yeah. So if you say you want to include this one, can also. Yeah. But if you include or you don't include, you end up in the same. You end up in the same thing because top bottom is -3, so it will cancel each other out. Yeah.
Sure. So meaning we can ignore the 10 to the power of -3 when doing the absolute uncertainty calculation.
Yes, correct. Correct. Yeah, but not in the actual calculation. Not in the actual calculation. For example, your for example, R equal to E over I, right? is a 9.4 over 1.0 times 10 minus 3. You don't do 9.4 over 1.0. This one is incorrect. You
Okay.
must include the power, for actual value. This is the actual value. If it's for uncertainty, you can get rid of the minus 3 lah. Hope that
Okay.
help you.
Yeah.
All right.
Thanks, teacher.
See you again tomorrow. One more class.
Mm.